In this video, we're going to be looking at doing calculations using standardized normal distribution. So here I've made a quick, rather ugly sketch of the empirical rule. And the empirical rule, we were looking at this normal distribution. This normal distribution was a standardized normal curve. So in a standardized normal curve, our mean is just going to be 0, right? And this +1, +2, +3 standard deviations is really just going to be +1, +2, +3. Those are our z-scores, and -1, -2, -3. And now we have our standardized normal distribution with our mean of 0 and our standard deviation of 1. So I'm just going to make a couple of notes here on notation. It's not something I love, but it's something I want to bring up. You'll see it on the homework, so I want to make sure that we cover it. So let us draw the normal curve for a situation that says this. Okay, this notation means find the probability that a randomly selected data value has a z-score of 1 or less. Now, this problem means the same thing as this notation. Less than or equal to or less than give us the same exact answer. It actually doesn't matter in this case. Okay, where in a lot of problems in Algebra 1, it mattered a lot. Okay? And if we think of a normal curve, okay, there's our mean of 0. Here is our z-score of 1 at our inflection point. Less than or equal to just means that we are looking for this area, okay, going to the left, right? So less than means left. Okay, so if we look at another example, let's look at probability where z is greater than 1, okay? Or z is greater than or equal to 1. Remember, it's going to result in the same answer. So this time, here's your curve, mean of 0. Here's our inflection point. Our z-score is 1. And this time, we're just looking for the area going to the right. Okay, and then finally, if you see something like this, or probability of 0 is less than or equal to z, which is less than or equal to 1. Okay, so basically this is saying that z is between 0 and 1. Let's draw this curve. It's ugly. Doesn't really look normal, but we're going to go with it. I don't know if I can go with it. I think I have to erase it. There we go. That's a little better. Okay, so 0, our inflection point, our z-score of 1. So we're looking for an area between those two. So that's what it would look like on the distribution. So I'm not going to go ahead and calculate these areas right now. I just want you to be able to visualize them. In class, we're going to use the calculator, and we will calculate all of those using the TI-84. Okay, I'm not even going to bother doing these examples right here because I think the video is self-explanatory.